This is our geometry semester final review, and this is just for part 2 of the final. Part 1 has already been recorded and made available to you. Now, what I want you to know is that this review is the exact concepts that you will see on the final. It's not necessarily the exact problems, but it's the exact concepts. So, another note that you might need to make is that you will be able to use your text and notes on the final. And please don't be tempted to look up your answers on the internet, because if I suspect that answers have been copied from the internet, you will receive a 0 on the final. Okay, here's the instructions. Oh no, you can't save this whiteboard. I'm sorry, because this is a recording. In the doc sharing, you're going to find, you won't find your test there. Your test is in the navigation bar under Unit 7. But in the doc sharing, you will also find postulates, theorems, and corollaries that were going to be covered on this test. And you might want to get a copy of the geometry formula chart if you don't already have a copy of it available, because you will need it. Okay. One of the first questions, or one of the questions that you're going to see, is use the area ratio to calculate scale factor and then determine volume of a cylinder. So you're going to have to figure out what the scale factor is and then use that scale factor to calculate the volume. So it says the surface area of two similar cylinders are 6 pi foot squared and 54 pi feet squared. If the volume of the smaller cylinder is 6 pi foot cubed, find the volume of the larger one. So the first step that you're going to do here is calculate the area ratio. So if you look in the first sentence of the problem, it says the surface area of two similar cylinders are 6 pi feet squared and 54 pi feet squared. So you're going to use those numbers to calculate your area ratio. So you start out with 6 over 54, and okay, it is there. So you're going to start out with 6 over 54 equals 1 over 9 right here. Actually, the 6 over 54 reduces to 1 over 9. Now I'm going to use that area ratio to calculate a scale factor. Okay, so remember that area is squared. So when I figured out this area ratio, that's going to be the square of the scale factor. So what I'm going to have to do is calculate what the square root of 1 is and calculate what the square root of 9 is going to be. And of course, the square root of 1 is 1 and the square root of 9 is going to be 3. So now I know what my scale factor is. So I can use this scale factor to calculate the volume ratio and then multiply by the volume of the smaller cylinder. And that looks like this. I'm going to take that area, the scale factor that I just figured out, 1/3, and since I'm dealing with volume, that means I'm going to cube my scale factor. Okay, so 1 cubed is 1, 3 cubed is 27. Now then, it's set up in the problem. It says that the volume of the smaller cylinder was 10 pi feet cubed. So look here, I put my smaller numbers in the numerator, okay, and I put the numbers that are larger in the denominator. Now I've set up a proportion, and all I have to do is cross multiply and divide to solve for x. So 1 times x is going to be x, 27 times 10 is going to be 270, and now I'm going to put that pi on there. I left pi off before because I really didn't need it until the end. So it's going to be 270 pi feet cubed is the volume for the larger cylinder. But I just want you to pay attention. I figured out the area ratio. I got the square root of that area ratio because area is squared. Since I need to calculate volume, I had to take that scale factor and cube it so I could calculate the volume. And then I used a proportion to do that calculation. Okay, another problem you're going to see is setting up proportion using ratios and solve for a missing length. And if you'll remember, this was called indirect measurement in Unit 3, and you're taking values from the two triangles that you have and figuring out some lengths. So let's read the problem. It says a person who is 6 feet 6 inches, which would come out to be 6.5 feet tall, cast a shadow from B to A. So look right here, I'm starting with this person as at point B, and his shadow goes all the way to point A. And that's going to be 6 feet long. The distance along the ground from the person, which is point B, to the tree is going to be 9 feet. They want us to take that information and find the height of the tree. So my first step is to label the figure with all the information they gave me. They told me this guy's shadow is 6 feet long, he's standing 9 foot from the tree, and he's 6.5 feet tall. So we got that all labeled. Okay, so what you're going to do is set up a proportion to find out what the height of the tree is. So look how I'm setting this up. I'm taking the height of the man over the length of his shadow, and I'm going to set it equal to the height of the tree over the length of the tree shadow. So when I do that, the guy's height is 6.5 feet, his shadow is 6 feet long. We're looking for the height of the tree, which is represented with the points DC, and to find the height of the tree, this is the trick, and I've noticed a lot of people making this mistake this semester. To find the height of the tree, I'm going to have to combine the length of his shadow and how far he's standing from the tree, because if you look, let's go back a slide. See how I've got the height of the tree over the length of the tree shadow? Well, the tree shadow includes from point C to point A. So that's why I have to combine 6 and 9. And that's where I get 15. So now all I got to do is do my cross multiplication and do my division. So when I cross multiply, I get 6.5 times 15 equals 6 times DC. 6.5 times 15 is 97.5, and it's still equal to 6 DC. So now I'm going to divide both sides by 6, and I get 16.25 feet squared, and that is going to be the height of my tree. Sorry, I thought I had that written out down there. So my height of my tree is going to be 16.25 feet squared. Okay, another concept that you've learned that you're going to have to practice on the test is to use the, or actually to calculate the surface area and the volume of a pyramid. Now the instructions say use the figure of the square pyramid to answer the following questions. Find the total surface area of the pyramid and find the volume of the pyramid. So what you're going to do is look at your formula chart and decide which formula you need and write it down. Well, part A says we're going to look for the total surface area formula for a pyramid. And that's what it looks like. It says surface area equals half the perimeter multiplied by the slant height, and then I'm going to add to that the base, the area of the base. So remember, capital P is going to equal the perimeter of the base. Capital B is going to be your area base, or the area of the base. So I'm going to look at the formula and I'm going to identify the variables, and then I'm going to calculate their values. Okay, so my variables are, I'm looking for surface area, so I know I need to find that. But the variables in the rest of the formula, P for perimeter, L for slant height, B for area of the base. So first P, which is perimeter of the base. What is the shape of the base? Well, if you look up in the instructions, it says use the figure of the square pyramid. So I know that this base here is a square. So that means each side of the base is going to be 8 feet. Okay, so it's a square, so all sides are the same length. So since all sides are 8 feet, I'm going to say 8 plus 8 plus 8 plus 8 equals 32. Now my slant height, if you look, they gave me two different heights. They gave me the height of the pyramid, which is this dashed line in the middle, okay, which is 7 feet. And then the slant height is this height over here that's actually the height of one of the triangles, okay? And that's called the slant height of the pyramid, and it equals 9. So I don't have to do any calculations, just fill it out. Then I need to find the area of the square base. Well, remember your area is length times width, which in this situation is going to be 8 times 8, which equals 64. So I have found the values of all my variables, and my next step is going to be to just plug in those values and calculate. So plug and chug. Plug in 32 for the perimeter of the base, a 9 for the slant height, and a 64 for the area of the base. And you can actually key this all into your calculator, or you can do it one step at a time like I did here. So a half of 32 times 9 is going to give me 144, and then when I add 64 to that, I get 208. So the surface area of this pyramid is going to be 208 feet squared. Now remember, that was just part A. I've also got to find the volume of the pyramid. But believe it or not, it's going to be easy because I've already done a lot of the calculating. You got to look at the chart and see what your formula is. And when you do that, you'll find out that your volume formula for a pyramid is 1/3 the area of the base times the height of the pyramid. Your next step is still to identify the variables and figure out their values. So I've already figured out what the area of the square base is, and if you'll remember from the previous slide, it was 64. And then the height of the pyramid's given to us, it's just going to be 7 feet. So all I got to do now is plug and chug. Plug in my numbers that I figured out. 1/3 times 64 times 7. That gives me approximately 149.3. Whenever you're multiplying by a fraction that is a repeating fraction like 1/3, you're always going to get an approximation. So you need the squiggly equal signs. Now volume is approximately 149.3 feet cubed. And notice how we included that word approximately. Another concept, calculate measure of inscribed angles and intercepted arcs using theorems and your knowledge of triangles. It says the diameter of circle C is 12 centimeters. The measure of arc DB is 20 degrees. They want you to use this information, the diagram, and your experience in geometry this semester to answer these questions. And they're also allowing you to use 3.14 for pi. Now notice each one of these steps, it says find the measure of angle ZWX and explain. Now remember, the explain says you need to write something out, explaining to me why you know that measure equals what you determine. We're also going to find the measure of angle XZW, find the measure of angle ZXW, and then we're going to find the length of arc XZ. And when we find the length and when we're finding these angle measures, you always need to show your work. So number 1 said find the measure of angle ZWX and explain. So I'm going to label the figure with what they've given me. They tell me the diameter of circle Y is 12 centimeters. They tell me the measure of arc XZ is 20 degrees. And I put an arrow here showing you what angle it is that we're looking for the measure of. So now it says identify the angle you need to calculate, and that's what the arrow was for. It disappeared. Oh, now it's back. Okay. This is an inscribed angle, so you need to decide what formula/theorem will help you find the measure. Well, if we look in that list of postulates, theorems, and corollaries that we have in Doc Sharing, we'll find theorem 9.6, which is the inscribed angle theorem. And it says an angle inscribed in a circle has a measure that equals 1/2 the measure of its intercepted arc. So now all we got to do is the math, okay? We got to take the measure of ZWX equals half the measure of arc XZ, which they gave us the measure for. So we know it's going to be half of 20. So the measure of angle ZWX is going to equal 10. Now the explain part, okay, is going to be the words in theorem 9.6. Don't tell me theorem 9.6, okay? You need to tell me that an inscribed angle has a measure that equals 1/2 the measure of its intercepted arc. That is explaining. And let me go back to that. So the answer that I would expect to find on the test, I'm going to highlight. I would need you to do this. This is called showing your work. I need all that information. Where it says find ZWX, that's everything I just highlighted right there. And then for the explain part, that's going to be this right here. That's all you have to write down. You don't have to do all of this that I did, just the highlighted parts. Okay. Part B said find the measure of angle XZW. Identify the angle you need to calculate the measure of, and there's an arrow pointing to it. Notice that angle XZW is inscribed within a semicircle, and there's a corollary for that. It's corollary 9.1. It's a right angle corollary. It says an angle that is inscribed in a semicircle is a right angle. So the measure of angle XZW equals 90 degrees. And I believe that's it on that slide. So what I'm going to do for find the measure of XZW, that's all you can do is right there. The explain part is really what you have to show in this one. Okay, so that's all I need you to do on your test is answer your question just like that. Okay, part C said find angle ZXW and explain. So identify the angle. I got my arrow pointing there. It says recall theorem 3.9. It's a triangle sum theorem. It says the sum of the measures of the interior angles of a triangle is 180 degrees. So in part A, we found out that the measure of angle ZWX is 10. Part B, we found out the measure of angle XZW was 90. So we use those measures to calculate the measure of ZXW. So we set our problem up just like that. Then we plug and chug. We plug in the information that we know. We combine the 10 and 90 to give us 100. Then we subtract 100 from both sides, and that gives us the measure of angle ZXW. So for the find the measure, this is all of the show your work, okay? And then for the explaining part, that's going to be this. Okay, so everything I highlighted is what you need to include in your answer. Okay, then part D said find the length of arc XZ and show your work. Now the length of which is L of an arc, where M is the degree measure of the arc and R is the radius, this is what that formula looks like. Okay, so I can find out that the length of the arc is going to be M over 360 multiplied by 2 pi r. Now remember, 2 pi r is how I'm calculating circumference. Okay? So really all I got to do here is plug and chug. So for the measure of the arc, I get 20, which right here is where I get the 20 from, because that's the measure of arc xz. And now I know that its measure is 20 degrees. I want to know what its length is. And it's in centimeters. Okay, so is it 2 centimeters long? Is it 20 centimeters long? That's what I'm looking for. Now then, you're going, well, where did you get that 6? That's not in the diagram anywhere. Well, if you look here, they told me that the diameter of circle Y is 12. Okay, well, our diameter is always twice, our radius is always half the diameter. So 12 divided by 2 is going to give me 6. So that's where the 6 came from. So I can enter it into the calculator the same way that I see it there, except for pi. Instead of using the pi key, I just keyed in that 3.14. So in parentheses, I got 20 divided by 360 multiplied by 2 multiplied by 3.14 multiplied by 6, and my answer ends up being 2.09. So, well, I was pretty close, and I wasn't even trying to guess. I was just throwing out numbers. So the length of this arc xz is 2.09 centimeters. Oh, and that's all the concepts that you're going to be tested over on your final. And I sure appreciate you listening, and I've enjoyed having you in class this semester. Thank you.